Let's do this problem right here. The question is asking use the cofactor method to find the third column of the inverse matrix of A. So let's see how we can do this. So first of all, in third column of inverse matrix mean, we are doing, this is the equation for inverse matrix. A inverse is equal to 1 over determinant of A time cofactor A transpose. So in this case, when we transpose this one, our third row is going to be the third column. So when they ask third column of the inverse matrix, it means third column of third row of the A. So if I take this one, so first of all, I have to find determinant A, cofactor A transpose. So we are only going to find the cofactor A for this one, because that's what we need for the final answer. And first calculate the determinant A. So to find the determinant A, I have to take this matrix right here, 2, 1, minus 1, then 3, 1, 1, then we have 4, 1, 2, then I have to put plus, minus, plus, and if I calculate the determinant of A, this will come out to be 2, and when I take 2, I have to eliminate all the vertical and horizontal component of this one. So we will have 1, 2, 1, 1, 1, 1, 1, 2. So I have to do the AD minus BC in this one. So AD is going to be 1 times 2 is going to be 2. 2 minus 1 is going to be 2 minus 1 is going to be just 1. And the other one I have to take minus 1. And if I take minus 1, I have to eliminate all of this. So it's going to be 3, 4, 1, 2. So if I multiply 3 by 2, it's going to be 6. 6 minus 4 is going to be 2. And the third one is going to be minus 1 times 3 times 1 minus 4 times 1. So it's going to be 3 minus 4. 3 minus 4 is minus 1. Then this will come out to be 2 minus 2 plus 1. Then 2 cancels each other. So the determinant A is equal to 1. Now I have to find the cofactor A transpose. So cofactor A transpose of the third column. So I'm taking these three values. So if I pick the 4, so this is a cofactor equation. So if I pick the 4, I have to consider the location. It's in the first column, third row. So I have to add the values. 1, first column, third row. Then I have to multiply the determinant of this one. The determinant is going to be the same format I did here. It's going to be when I take this value, I have to eliminate all the vertical and horizontal components. So I have left with 1 minus 1, 1, 1. So 1 minus 1, 1, 1. And then I have to do the same thing for other things. So if I calculate this one comes out to be 1 times 1 is going to be 1, minus 1 times minus 1 is going to be minus 1. 1 minus minus 1 is going to be 2. And if you add this power, it's going to be 1 plus 3. So it's an even number power. So the answer is going to be positive 1. So positive 1 multiplied by this 2 is going to be 2. Then I'm taking the second value. It's going to be minus 1, and the location is second column, third row. So it's going to be 3 plus 2. And determinant of this one is going to be when I eliminate these vertical and horizontal components, it's going to be 2, 3, minus 1, 1. So 2 minus 1, 3, 1. And if I do the AD minus BC, it's going to be 2 minus 3 is going to be 5. And in this one we have a odd power. 3 plus 2 is an odd number. So if you power this negative value with this odd power, you are going to get a negative number. So it's going to be negative 1. Negative 1 times 5 is going to be negative 5. Then the third one we are doing. Third one is minus 1. The location is 3, 3. Third column, third row. So 3 plus 3. Then the determinant is going to be when I eliminate these components, is going to be 2, 3, 1. So 2, 3, 1. And if I do the AD minus BC, it's going to be 2 minus 3 is going to be minus 1. And it's an even pump. It's an even power, so it's going to be the same answer, minus 1. Now we have found these values. Now what I have to do is I have to plug in this formula. So it's going to be A inverse is going to be equal to 1 over 1, determinant is 1, so I put 1 over 1 times cofactor A transpose. That's what we have found here, is 2 minus 5 minus 1. So if I multiply this one by this one, I will get the same answer. It's going to be 2 minus 5 minus 1, and that's my final answer. And the second question is asking, if A is a 5 by 5 matrix with determinant A is equal to 2, then find the determinant of cofactor A. So in this case I have to use the same formula. A inverse is equal to 1 over determinant A multiplied by cofactor A transpose. And in this case I have to take determinant of everything, because we are finding determinant of cofactor A, so I have to do something with this determinant. So let's do this. Determinant of A inverse, and 1 over determinant of determinant A is going to be, so if we take determinant of determinant A, so 1 over determinant A, and then cofactor A transpose, determinant of cofactor A transpose. Determinant A inverse can be written as 1 over determinant A, and this is a number. So for the 1 over determinant we have to deal it as a number. So in this case what's going to happen is, when you determine take a determinant of number, you have to power by this value, 5 by 5 matrix. So if it's 4 by 4, you power by 4, like whatever the matrix we have to power with the same number. So in this case we are going to power this one by 1 power 5, and this is going to be determinant A power 5, and cofactor A transpose. So when you have a determinant A transpose, it's going to be determinant A. If you have determinant with something transpose, it's going to be determinant of that value. Like determinant B transpose is equal to determinant B. That's a general thing to know. So in this case, that's a property of determinant. So when you have a determinant transpose, that's going to be a determinant of itself. So when you have determinant cofactor A transpose, you can try to get the determinant of cofactor A. Then to find this determinant cofactor A, I had to switch this around. So we know this determinant A is 2. So we can plug this value. So if I bring this to the other side, it's going to be 2 power 5 over 2. And in this one, 1 power 5 is going to be 1, so we don't have to do anything. And determinant of cofactor A, that's the question. That's the one we have to find. So determinant of cofactor A is going to be equal to 32 divided by 2. And this is equal to determinant of cofactor A. Therefore, determinant of cofactor A is going to be equal to 16. So this is the final answer. And that's how it's done. I hope you guys like this video. See you next time.